Let's take a look at how we've used blueprints to animate this truck to follow a path. Before we get started though, I'd like to point out that for this task, frame rate is very important. So to ensure we're all seeing close to the same thing, I've brought in the level blockout in place of these high-res meshes. That'll just make sure that we're running at a high frame rate so all of the animations and timing work out as expected. So we'll begin by clicking on this path and just opening up the truck path blueprint here. As you can see, the event graph is empty, and that's because there's no logic required for this. All we're doing is creating essentially a target path that has this spline actor in it. So if you head to the viewport, you can see that it's really just this single line with two endpoints, and that's just a basic spline component. So we'll head back to the scene. Next, let's take a look at the truck. So you can see it's called Truck Dynamic Blueprint. And if we edit that and open it up, you'll see that there's sort of a lengthy section of code here and then a little snippet down at the bottom. For this video, we're going to focus on this top section. And I'm just going to walk you through essentially the step-by-step process of how this blueprint is calculated so that you can learn the basics of process and maybe get some useful tips on how to organize some of these nodes. The essential logic behind how this truck operates is there is a target spline that it's following that we just looked at. And essentially it starts off by setting its location to the endpoint of that spline. And then it just moves along that spline by changing this distance along spline variable. So as you can see, its default is 0. That's where it begins. And then every tick, this event will fire and it will start adding whatever we've set as our speed. So in this case, it's 900 units. That's kind of an arbitrary number. You'll want to adjust this according to how it plays in your scene to something that looks right. But essentially what we're doing is we're just adding this number every tick to the distance along spline variable. And I'll kind of just zoom out and skip to that part. So every tick, it runs through this node and sets the variable distance along spline to a new value, which is essentially its old value plus the current speed multiplied by this value here, get world delta seconds. This essentially just handles the offset between if your frame rate is running low or fast. This essentially compensates for that. So now that we've got this variable, distance along spline, that's every frame is slowly increasing in number until eventually this distance along spline variable will equal the length of the spline and the truck will reach the end. Now, how do we move the truck to a specific location according to this variable? That's essentially what this node is doing. So once we verify that the spline that we're targeting is valid, we fire this node, set world location and rotation. Now it's asking for a target and a new location and rotation. These we can get from that spline. The target is the truck. And as you can see, I've called it truck base because we have a scene component that we're making the truck a child of, which essentially just allows us to adjust the truck separately, and the base is actually the thing that will follow it. In our particular case, it's because the axis of the truck does not match that of the spline. So to get this new location and rotation, what we need is this function get transform at distance along spline, and that's where we input our spline target path as its target, and the current distance along spline as the distance. And make sure your coordinate space is set to world. If it's set to local, the truck will move according to the shape of the spline, but it won't necessarily follow it. So, for example, the truck could be 50 feet to the left and still follow the shape of that spline. Maybe it has a curve or a turn, but it won't actually track the shape and location of that spline. That's because local space is according to the truck itself in this viewport, independent of the scene. And so we want to make sure that this is world. And then this other node is essentially just an extra piece that I've added. What it's doing is it's setting the same world location and rotation as the truck, except it's for the trailer. And the way that I handle kind of a more realistic turn where the trailer kind of lags behind is I just take that same distance along spline, but then I subtract 400 units from it. So as far as its location, and in this case, we're just looking at rotation, that will kind of lag behind. So as the truck turns, there'll be a moment before the trailer starts to match that turn. So it seems like it's a little bit more realistic. So now that you've seen basically how that spline trace works, let's go ahead and hit compile, jump back into our scene, and just watch this play out. So what we're expecting is when I hit play, it will begin by setting the location of the truck to the spline, and then every tick it will add to that location so the truck appears to move along that spline. And there we have it. In the next video, we're going to look at how we handle this stop and start so that we can add even more complex logic, things like these stop signs.